Let's take a look here. What's going on? Good morning to you guys here. Who do we have here? Good morning, Charlene. Alyssa, good morning, or good afternoon. I don't know. John, good afternoon, good morning. And Jimena, good afternoon, good morning. Good morning to all of you guys, or good afternoon. Don't know what exactly it is. Anyway, where do we leave off in our notes? Do you guys remember? If I go back and we try to find out where we left off in our notes, this was for the Titanic, is that true? Yeah, we're looking at odds for an event, odds for surviving, and then we left off what we call unitizing. So we're going to use some of that information today. Unitizing, meaning the odds for surviving the Titanic was 706 to 1517. Yeah, thank you, John. Okay, you guys remember we left off with that. Now, I want to talk about here odds for surviving. We can unitize it, and I was in the process of showing you guys how to unitize. Like, for example, we can take any ratio here, A to B, and I'm dividing both of these by A, so I end up getting 1 over B over A. So I'm going to give you kind of like a formula here for unitizing. Okay? So just kind of go where we left off. So if I had to unitize these odds here, you said, okay, how does that apply to what we're looking at here? Remember that Titanic mortality table? 706 survivors to 1,517. So I want to unitize the survivors here. So divide both of these quantities by 706. Notice what you get now. Right? You'll get here 1 to 1517 over 706. So we want to find what that number is. Let's try to do that here, right? We're going to look at the calculator here. I got my TI. So 1517 divided by that 706, where we left off. This is about 2.1. Okay, so let's kind of see what that means here if we go to the nearest tenths there. Right? You might say, what does this unitizing mean? Well, that's 1 to 2.1. Let's look at the quantities, right? What does this represent? Right? You guys remember what 1 represents? In orange, that represents the what? Survivors. And then what does this 2.1 represent? The non-survivors. Okay? So this unitizing process gives us a good idea about survivability on the Titanic. Does that make sense? There's 1 survivor to every 2.1 what? Non-survivors. This is the odds for surviving on the Titanic. This is where we left off in our notes. And that's going to be irrelevant for what I want to talk about today, ladies and gentlemen. So this is the odds for surviving, but it's not 706 to 1517. It's unitized for 1 survivor to 2.1 non-survivors. Yes, we have a question. Yeah. Well, when I divide right in here, right? We do this computation here. Oops. Let me undo that. So we did a division here, 1517 over 706. 706 over 706. We are free to divide both quantities of a ratio by any number we want. But we did it by 706 to get the idea of a unit. This is a unit ratio. Unit meaning the number 1 right in here. There is 1 survivor to every 2.1 non-survivors. So we're looking at the survivability rate there on the Titanic. 1 survivor to every 2.1. So you kind of think of it that way, like here's 1 person who survived, and then here's 1, here's what? 2, and then here's like 0.1 of a person. Okay, that gives you an idea of surviving to what? To not surviving. So this was the definition of odds that we looked at last time. but we unitized it. Survive. Unitizing meaning 1, because that gives you an idea of whole numbers 1 to 2.1. So that should give you some sense of the survivability on the Titanic. What do you guys think? Every survivor, there was 2.1 non-survivors, people who didn't survive. And all we did was unitize the odds definition that I gave you guys last time, odds for an event. Okay? Now, this is a measure of chance, and that came from our Titanic data representation here. So I just wanted to finish that one off, and I couldn't last time. So this is odds for surviving the Titanic. Now, if we compare that to, now let me give you another definition. Remember, this is one of my favorite definitions in probability. This is the definition of what we call a conditional probability. This is used very often. We use this conditional probability to compare groups of people. So this is one of my favorite definitions. This is how we compare to, or, compare to mutually, or I'm just going to say this. We compare mutually exclusive groups. Did we talk about what that meant, mutually exclusive? Well, the intersection is empty, meaning, for example, men versus who? Women, right? Mutually exclusive meaning that the intersection of the list is empty. There's not a single person who's both a woman and a man at the same time. Those lists are kind of separate. There's a lot of lists that are mutually exclusive. Boys with girls. Okay. Men versus boys. Okay. We can look at ethnic groups. Asian versus white. And maybe I should write down some of those terms here. So I just want to let you guys know we're going to compare groups today. All right, mutually exclusive. Just any two groups where you don't have a single person in common. Okay, so I'm going to use what's known as a conditional probability here. Let me erase this for you guys. We're just going to use this to compare. And this is a very important definition now with probability. So let me write this down in words first before I give you the actual definition. This is going to be the probability of an event A given some condition. Okay, so here's the probability of an event, and then I'm going to emphasize the phrase, given that, and you have given that some condition here. This is B. This is known as your condition. And this is known, or this has actually happened. Okay, so this is, I'm going to define this for you guys. So for example, here are the symbols that we use. Probability of A, and this vertical line means what? Given that, and then what does this be? That's your condition. That is known, that has happened. And that's a ratio, a fraction. And this is out of now the total number in B now. Okay, total number here in B. And you need the number of A and B. So we have the number of A and what's this condition? And B. Is that right? This is a conditional probability. And I'm going to say, get to know this definition because this is used to compare, ladies and gentlemen. It's used to compare. So this is what I mean that it's used to compare. Now let me go back and double check. I didn't give this to you. These are all the notes. Yeah, okay. Let's go back to the Titanic here. See if I can find it here. All right. Here's what I'm going to say to you guys. Who's more likely to survive, do you think? Here's my big question. Who was more likely to survive the Titanic? I'm going to have to look for my Titanic information. What do I have? What is this? There we go. I'm going to bring it in. And I'm going to compare two groups. I'm going to say men versus who? Women. Okay? So who's more likely to survive the Titanic? And in what sense? Men versus women. And that's not what I want to look at. I want to look at this here. So in order to answer that question, let me kind of remark to you guys. I'm going to use the conditional probability definition. Okay? Let me express to you the same exact question as conditional probabilities. Like, for example, you select a passenger on the Titanic, they're going to want to know, what's the probability the passenger Question 1. Survived, given that the passenger was a man. 2. Survived, given that the passenger was a woman. Okay, this is really, bless you, what we'll be using. So you say, what do you mean? This is the event. You survived. And what does this phrase say? Given that. You know what that means? The second you read the phrase given that, that's a conditional probability. They want to know now the probability you survived here, given that what? Oops, different color. Given that you are now who? A woman. So this is going to tell us which passenger was more likely to survive the Titanic, men or women. All right, just to kind of let you guys know, this is a conditional probability. Love this definition. So compare probability. This is the definition. You survive and you're a man. Let me write it all together. Right? So the first one's going to be symbolically probability you survive, given that you're a who, you're a man. That's defined to be, ladies and gentlemen, number of survivors and men over the number of who? Men. This is your definition. Okay, you're going to also use probability you survive, given that you're who? A woman. Number who survive and are who? Women out of the total number of who? Women. All right? So notice the colors here. This is the chance of that event, probability of surviving, reading it left to right. Probability of surviving. And then you see this vertical line? What does that mean? What does that vertical line represent again? The phrase given that. Good. That's what it represents. Given that you are who? A man. Given that you're a woman. That's the condition. So this is now of all the men, of all the women, right? How many of them actually survived? You're going to have to use this definition. Don't forget this here is and. This is and. It's a conditional probability. Comparing those two. And let's find this out. Let's see what we get. Where is our chart now? Okay, so let me share with you guys here how to read this here. Okay, so the first one says this. Could you guys tell me for the first question? How many men are on the Titanic? How many men? 1,692. Good. That goes right here. Okay. Now, of the men, how many survived? Of the 1,692 men, how many survived? Because that's the numerator. You are surviving, and you are a who? Man. Is that right? So let's go back, and what I'm going to do is I'm going to open, see if I have the Titanic. I think I should. No. So I'm in Excel. File, open, recent, maybe. There we go, Titanic table. Because sometimes people have trouble seeing what we're talking about, right? So you're saying, hey, Mr. Judge, how do we know how many men are on the Titanic? Well, take a look. In that column, isn't that the man column? Okay, now that's, well, the total was 1692. That's how we have the denominator. But now we're looking at how, of the men, how many also survived? What do you guys see there? 300 and what? 32, ladies and gentlemen. So that's what they're looking for here now. 332 divided by 1692. So we're going to use, I'm going to get rid of this here. All right, we're going to use the TI. Let's find that ratio. Ratios are fractions, by the way. 332 divided by 1,692. Ladies and gentlemen, what do you get now? Let's approximate this to the nearest thousands again. What do you guys see? Isn't that 0.19 what? Is that 0.196? Okay. This is the probability. What does that mean as a percent? 19.6%. So, ladies and gentlemen, 19.6% of your passengers survived, given that there were men. In other words, of the men now, this is the men group. Of the men, 19.6% of the men survived the Titanic. Really good. All right. I bet you guys thought they all died. Is that right? No, about 19.6% of them. What's the deal? Survived. That's a good thing, don't you think? This is of the what group? Of the men. We're going to compare that to the who? To the women. And in order to do that, what do we need to know? We need to know the number of women. And of the number of women, we need to know how many of those survived. So there's two fractions we have to find, right? So we're going to go back to Excel, and what we're going to do here is this. Let's get rid of that. How many women were on the Titanic? How many? What does it say? Is it 422 women are on the Titanic, ladies and gentlemen, down there? Okay, of the 422... how many survived? 318. Okay, you guys see that there? Survive row, man column, And ladies and gentlemen, in the TI there, let's find that ratio. 318 divided by 422. Anybody know? What is this approximated to the thousands now? 0.75 what? Is that 4 or 3? Looks like approximate to the nearest thousands. And yes, ladies and gentlemen, 0.754. And what is that approximated, or how should I say, what's that percent? 75.4%. So what do you guys think about this here? Let's compare. Which group was more likely to survive here? Men or who? This is now who? This is the women. Which group was more likely to survive? Women. Why is that? They have a higher probability value. Outstanding. All right, so higher probability value. This one is more likely to survive of the two. What do you guys think? Is that a pretty good definition? I want you guys to note a few things here, though. Let's say, by the way, let's note. What's the probability of surviving in general? Of just surviving. You're not looking at any group in particular. You're looking at overall, the whole total there. I want you to look at the difference in definitions. The probability of surviving is the number who survive out of the what? Total. So I want you guys to just compare and contrast what we've just done. Okay, compare and contrast. If I go back here to Excel and I simply want to know the chance of surviving, everyone in general, of all the groups, men, women, boys, and girls, and we somehow lost that color. No. Let's get this here. I don't remember what color we used. There we go. How would you actually use the definition of probability to answer this question? Right? Could you guys tell me how many people survived on the Titanic? 706 survivors. That's in my numerator. Is that right? Right? 706 here. Over what? 706 divided by what? The total. Right here. 2,200 and what? 2,223 in the sample. Okay, I just want you guys to compare and contrast this because I don't want you guys to confuse these ideas. One's the general chance of surviving, not considering a group that you belong to. So the general chance of surviving, ladies and gentlemen, the Titanic is 0.318 as a probability. 0.318. And what does that come down to? 31.8%. And there it is. Okay, but if we start looking at different groups, that's going to change. Is that right? Okay, so know the definition of probability and know the definition of conditional what? Probability. That's the idea. Okay? Let's take a look. This is 3. What's the probability you survive given that you're a who? Boy. So we're going to look at the children now, and we're looking in particular the boys. Now, this is a conditional probability, right? How do we know when we read this phrase? What's the tip off? It's a conditional probability. The phrase what? Given that. You guys okay with that? Given that you are what? A boy. So when I see this, I write this down. The probability you survive Given that you're a boy. I go, oh, okay. It's the number of surviving boys. Divided now by the group, the total number of boys. We are looking at just the boys. Okay? Just want to remind people, this is a group of boys now. That's known, that's happened. We're looking at boys here. We're considering only the boys. So again, I have to have two numbers again. What do I have to have? You guys remember? What do we have? How many boys are on the Titanic? 64 boys. You guys okay with that? All right. 64 boys. Okay, of the boys now, how many of those boys survived? 29. Do you guys see that intersection there? You're a boy and you survived. Okay, that's what we're looking for. 29 out of what? 64, ladies and gentlemen. Let's approximate this to the nearest thousandths position. And 29 divided by 64, what do we get? 0.45 what? 3. 0.453. Okay? All right. What is this as a percent? 45.3%. So we can say 45.3% of the passengers on the Titanic, what happened to them? They survived. What do you guys think about that? Is that a good comparison, right? Let's compare that to the probability you survive given that you are a girl now. Girl. Let's find that probability. Survived. Given that you are who? A girl. So I write this down this way. Probability you survive. Given that you're a girl, okay, it's the number who survive and are girls out of the total number of girls. All right. How many girls are on the Titanic? 45 girls. Of the 45 girls on the Titanic, how many survived? 27. Is that right? So this probability is going to be 27 out of 45. Let's approximate that to the nearest thousandths. So we hit 27 divided by 45. And ladies and gentlemen, this is going to be what? It's 0.6. And it's not just 0.6. It's not even approximate. It's equal. Does anybody happen to know what 0.6 is as a percent? What is that as a percent? That's 60 what? Percent. 60% of the passengers on the Titanic, what? Survived, or I should say, not of the passengers, 60% of who? Girls. So it's 60% of the girls survived. So comparing that to the boys, which child was more likely to survive, girls or boys? So I'm going to put that statement down so you guys know. Girls were more likely to survive the Titanic. Okay, girls were more likely. So I'm using the definition even of more likely. I'm using the language. And similarly, I'm going to say this. We can say this another way. We can say the boys were what? Less likely. Yes. to survive on the Titanic. So the boys were, in fact, less likely. What do you guys think? Not a bad definition? No? And these are, I'm going to say this to you guys, these are what we call survival rates. These are the survival rates. Why do you think they call it survival rates? Yeah, because in every one of these cases, it's a probability of what? Right in here, probability of surviving. Then you have given that. Probability of what? Surviving. Then you have given this other category. Okay, so you guys know this is, again, just general probability of surviving, but probability of surviving, given you're a woman, probability of surviving, given that you're a man. Okay, so these are like survival rates. You can have death rates. I'll just give you guys note, just a note. They could have asked you this question. This is just kind of a note or a by the way. There are some things called death rates. Now, I chose survival rates because sometimes that's a bit, talking death rate is like kind of pretty grim, right? Pretty dark stuff. But they can say, what's the probability of not surviving given that you're a who? Man. So just to kind of show you the idea that knowing your definition is everything, right? The probability of now not surviving, given that, it's a conditional probability, given that you're who? That you're a man. So we can have talked about everything in that right way, because what does not surviving mean? Do you guys know what not surviving is? That's dying. Okay, so I want to share with you guys, you can actually use the same definition, line given that, given you're who? A man. And that is the same. Of all the men, they want to know how many did not what? Survive and were who? Men. So this is the total number of men. Okay, you can still apply your definition. That's the whole idea. So knowing your definitions is something that's really important here. So notice, I got to go back to all the men now. Or again. So this time we're going to, okay, here's all the men. How many men were on the Titanic again? 1692. So you say, okay, this is 1,692 men that were on the Titanic. Now what do I look for if these are death rates? I don't look for the number who survived. I look for the number who did not survive. And in this case, that's the number who died. And how many men died on the Titanic? 1,300 and what? 60 men. So I'm going to have to take that ratio, 1,360 divided by 1692. The definition. 360 divided by 1692. What do you get now? What is this? 0.804. Is that true? And what does that give you? 80.4%. So this is the death rate. Of what group of men? This is the group. So I just want to let you guys know, we can talk about survival rates, or we can talk about what? death rates, you just use the same definitions. Not that big of a deal. Is that right? Just use the definition. What do you guys think? Okay, now if I just said to you again, by the way, what does this mean? The probability of not what? Surviving. This is a regular probability. There's no condition. Is that right? And what could I use to answer that question? What was this called last week? Probability of not surviving. What do we call this? Isn't that the complement rule? Right? So if I know the probability of surviving, don't I already know that already? Where is that? I know that already. That's right here. This is the probability of what? Surviving. It's 0.318. Is that true? So if I know this, copy it, I can use the complement rule here to find the probability of not surviving. That's 1 minus 0.318. So I want to go through these details just to kind of review because they're all extremely important. 1 minus 0.318, ladies and gentlemen. And what do we get here? What is this? 0.68 what? 2. So you might say to me, what's so important about this number, right? Well, 68.2% of our passengers did not what? Survive. And not surviving means what? Dying. 68.2% died on the Titanic. So, ladies and gentlemen, this is an extremely important detail. Okay? You're working with probability values, conditional probability values, and the complement rule. So, isn't this kind of the stuff we went over last week, some of these things? Do you guys know what I'm talking about? Okay. Now, what I want to mention to you guys is a couple of important things that are going on. If I go back to my website, of course, you guys are in Math 227. And I put up another page here. AB 705, AB 1705. Is it really a good idea? Which you guys seen last week as me speak about these things. So these are going to be some lectures of using the definitions we just talked about. All of that information so you guys could get an understanding of what I'm even talking about and referring to. Because that's important. We're using probability, statistics to look at how public policy shapes our lives or unshapes it, however we want to look at it. So here was that sheet that I'm going to be sending and talking about and hopefully presenting here to people. And this is in regards to the bill of AB 705 and AB 1705. Okay? Now, in this bill, we have what's called throughput. That's the number of successes and the number of non-successes. So I'm going to put this in the chat there. And I'll probably put some more things up. Sorry about that. There's that portion. We're going to be looking at this table today and talking about this information. But I did put up this weekend a video going through this as well. Okay? So I talked about this in a video here already, but we're going to go through some more information with that. And so far we have about 23 people looking at that. Is AB 705, AB 1705 a good idea? And I don't know, anybody here watch it by any chance? Because I did it live on a Sunday. Some of you guys might have, or who knows. I have about 2,000 subscribers. Maybe of those 2,000 subscribers, some people watched it, right? And I already have 1 like. So we're going to go through the mathematics behind all this stuff so you guys know. Okay, and if you said, I don't even know what that bill is, you can read about it right here. That's just about placement, by the way. AB 705 is about placement. In other words, what they have claimed about in this bill is that high school GPA is a better predictor about how well you'll do in taking a transfer level English and math course. In other words, if you have a high GPA in high school, they think you should just go walk into a transfer level English and math course. Before, they used to give you an assessment test and see where you were on the assessment test and would place you that way. So this is about placement. It's about directly placing students into transfer level courses. Okay? Now, they say for the most part, well, if you don't succeed, just try again. They say, well, I guess colleges can add what's called co-requisite courses. In other words, if you take this course, statistics, they might want you to even take another math course at the same time, designed to help and assist you, a whole other co-rec course situation. Now, we've tried that in the district. Mission College has tried that. They had no success, and I can express why later. But giving you guys a background behind all of this. And, of course, they say get extra tutoring. So, okay. They feel that you'll be better off doing it that way than the old way. And that's their opinion, right? AB 705. They had some data that they gathered to try to justify it, but their data is pretty biased because they kind of chose neighborhoods that are pretty different from the neighborhoods that you and I may have grown up and live in and work in here. They chose very different neighborhoods for this, and you're going to see all this come together for you guys. That's the beauty of using this as a background for learning probability and statistics. See how it all works. Anyway. All right, so here's what I'm going to do now for you guys. I kind of have some of this already from the morning class. And what I'm going to say here, let's go over to Microsoft Excel. Now, what I'm going to do now here is this. I'm going to get out of the Titanic world. And I'm going to go straight to fall 2018, 2019. And I'm going to clear the contents. Because that was from this morning. All right. I'm sorry. And I don't want any colors here. And here's what I've done from that worksheet I was describing to you guys that I put in the comment section. This is data gathered by the district for a lot of different ethnic groups. As you guys can see, what are the ethnic groups here? This is fall 2018, what they call throughput. We have American Indian, we have Asian, we have Black, we have Filipino, we have Hispanic, we got multi-ethnic, Pacific Islander, white, unknown, and total there, right? So there's a lot of different ethnic groups. What I did is I only chose 4. So I'm focusing on 4 different ethnic groups, okay? Just to keep it simple, to share with you guys these ideas. Now, notice what I have here. The first ethnic group I have, if I can get to Excel, where are you, Excel? This is the Asians. These are Black, white, Hispanic. And then this is the total of the 4 groups, okay? So here's what I want to share with you guys or show you guys how to do this here. I'm going to test you guys on whether or not you learned this definition. Let's go through it. This is fall 2018 data, okay? This is pre-AB 705. We're going to look at success rates. Okay? Success rates. So you might say, what are you talking about? So from this table, I'm going to say this. If you select a person at random, what's the probability the person was, is, was question 1, successful, given that the person was Asian. Okay? Probably the person is successful. Here's the phrase what? Given that, what's the group we're looking at here? Asians, ladies and gentlemen, Asians. All right, you guys with me on this? So what I would do personally is I'm going to write this down as probability you are what? Successful. I'll abbreviate successful. What does this line mean again? That means given that. And what's the group? Well, the Asian groups, or the Asian students. So probably you're successful, given that you're Asian. It's a number who are successful and are what? Asian over the total number who are Asian. Okay? So, I need two numbers again, right? Two numbers. Of all the Asians, here's the Asian group of students, right? How many Asians took Math 227? This is a Math 227 statistics course, statistic. How many Asians took Math 227 in fall 2018, pre-AB 705? 400 and what? 37. Of the 437 Asians, okay, how many were successful? So you're going to look at the what? Successful common. That's going to be how many now? Oops, let's get this here. Asian. Do we color it? And then what? Successful. What would you guys say? 314. Is that true? So 314 out of 437, ladies and gentlemen. So tell me, what is that ratio going to be in the TI calculator? Let's find out what that is. Let's clear this. 314 divided by 400 and what? 37. What did you guys get now? What is this? 0.7. Let's go to the nearest thousandths again. 0.71. What is this? 9. Good job. And what is this as a percent? 71.9%. Move the decimal 2 spaces to the right. So this is a success rate for which group? For Asian students, ladies and gentlemen. Fantastic. It's a lecture on conditional probability success rates. What does this stuff mean? Okay? And then now we're going to compare number 2. So probably you're successful given that you are black, what the district describes as being black. So you are successful. This is a conditional probability. You have the phrase given that. What's the group now? These are now black students. You're going to use your conditional probability definition again to find these rates. Probability you're successful given that you're black is the number who are successful and black divided by the number who are what? Black. You're going to use the definition. So we want to know how many black students took Math 227 in fall 2018 pre-AB 705. How many black students, ladies and gentlemen? Let's go take a look here. Let me go remove this. Where are the black students? Oh, second row. Let's actually get this here first. I don't know what I did. So here's the black students. How many black students took Math 227 in fall 2018 pre-AB 705? How many took it? 481. Okay. So there's actually more black students than Asian students that took it. Can you guys see that there? Okay, of the black students, how many were successful? 200 and what? 28. Okay, you guys got that there? All right, now let's see what this means here. All right. 228 divided by 481. 228 divided by 481. Let's see what the TI says. What's this going to give you? 0.47 what? 4. You guys with me on that? 0.474. Okay. So what is that going to be? Right? 0.474, 228 divided by 481. What is that as a percent? Move the decimal 2 spaces to the right. What do you get? 47.4 what? Percent. So, ladies and gentlemen, 47.4% of those students were successful. 47.4% of what students? Black students. Good. That is a success rate. Okay. For black students in Math 227, pre-AB 705, notice the difference between Asian students, 71.9%, and black students, 47.4%. Okay? 71.9 and 47.4. I'm going to put that right here. What was that? 71.9% versus 47 point what? 4%. Do you guys see a difference in numbers here? I'm going to label this. This is what's called a gap. And you can call it an equity gap because it's regarding race. There's an equity gap there. All right, you guys okay with that? This is what's referred to as an equity gap. Meaning Asian students did a lot better than who? Black students. There's a gap there. Let's look at the next group. What's the next group? White students. Okay, let's write that down here. Isn't this a wonderful way of learning statistics here for your conditional probability? Looking at survival rates, death rates, success rates. This is all real stuff, ladies and gentlemen. This is the deal. So we're going to look at the probability you are successful this time, given that you are what? White. So let's check this out. You're successful. Given that you are who? We're going to look at the white students now. This demographic. Okay, this is a demographic. So I'm going to write this down symbolically. The probability you survive, given that you're what? White. So this is the number of who? Survivors and white out of the number of white students. So let's see how we would do this now. Okay, let's see what this is. So now let's go to the Microsoft Excel now, and we say, okay, of all the white students, there we go, how many white students took Math 227, pre-AB 705? What did you guys say? 562. Do you guys see that there? Of the white students now, how many were successful? Of the 562 white students, how many were successful, ladies and gentlemen? 363. Outstanding. Yeah. Okay. Oops. Okay, now what we're going to do is this. Go to the TI. And you say what? 363 divided by how many? 562. And ladies and gentlemen, what's this approximately? 0.64. Is that a 5 or a 6 if we go to the nearest thousands? Outstanding. 646. Okay, ladies and gentlemen, 646. This is what we got from the TI. And what is this as a percent? 64.6%. Okay. 64.6% of which group now? Of white students. So now, of the white student group, which you now have, is about 64.6% were successful in Math 227 Fall 2019. All right, you guys okay with that one? You guys see what I'm saying? Now, let's put this in Excel. You say, why do I want to put that 64.6? Because I'm going to look at these rates. And why does it have double? Double, that's weird. What are these known as? Not percent. These are known as what kind of things? Equity what? Gaps. So you guys know what people are talking about now. Okay, you guys with me on that? So these are called equity gaps. Maybe we'll give that a special color. Is there a color? What color should we use? Orange? What should we do now? Let's look at the Hispanic group. Okay, these are equity gaps. Fall 2018, pre-AB 705. Okay, what we're going to do now for number 4 here. We're going to look at the probability of being successful, given that you're from what group? Hispanic. Now, Hispanic is a general term. Okay. Chance you're Hispanic. Conditional probability. The phrase given that, what's the group now? Hispanic people. Symbolically, probability of your success. Probability of a success. I got to get this right. This line means given that you're Hispanic. So the number of success and who? Hispanics out of total number who are successful. So, I'm sorry, I have a mistake. This is out of Hispanics. Okay? So we're just going to apply the definition that we've been applying, this conditional probability. We're looking at these demographics now. Okay? Here we go. Tell me, how many Hispanics took Math 227 in 2018, pre-AB 705? What's that number here? 3,956. You know, that's a pretty big number. That's almost 4,000 compared to the rest. That's about, what, 500? So there's 8 times many, more than 8 times the number of Hispanic students than of these other ethnic groups. You guys see my point? There's a lot more, ladies and gentlemen, Hispanics than the others. And so if we say, okay, 3,956, how many Hispanics were successful? What are you going to say? 1,903. Do you guys see that there? Okay, you guys okay with that? All right, you guys okay with that one? So what I'm going to do now here is this. Let's find the success rate for which group? For Hispanic students. The success rates. Let's find that out. Okay, so get out the TI. And 1,903 divided by, excuse me, 3,956. Those allergies are getting me again. What do you guys see here? So the nearest what? Tenths. 0.48 what? 1.481. And there we go. And then what is that as a rate here? What's 0.481? What's this as a percent? 48.1%. So what I'm sharing with you guys here is that 48.1% of who? Of Hispanic students passed Math 227 in fall 2018, that particular course, 227, they were successful. Okay. Now, let's go back here and put these rates. I'm going to undo these colors. Now let's ask you guys this question, 48.1. I don't know. Why is it doing that? What are these values called? These are equity gaps. Is that true? So if I ask you guys this question, of these 4 categories of people, groups of people, which was more likely to pass Math 227 in fall 2018? More likely. You guys are looking at it. Asian students, is that true? Okay, who was least likely to pass Math 227 in fall 2018? Who's least likely? Black students. Okay, so these are known as equity gaps, ladies and gentlemen. All right, so you guys know. What do you guys think? This is probability working in your everyday lives. This is what we're looking at behind the scenes of these bills, AB 705, AB 1705. The heart of the reasons why they claim that AB 705 was designed to fix equity gaps. This bill was designed to do what? Fix equity gaps. Okay, now this is before AB 705. So they go, okay, this is our picture pre. You guys ready to see what happened the first year of AB 705? I'm going to show you guys now what happened the first year of AB 705. Now, I'm going to ask you guys to do this because I'm going to make this lecture public. So everybody here who's in the audience that you said good morning and we put your face there, I want you guys to give me permission to release this. Say, permission to release. Can I release this on YouTube? Make it public. Asking you guys at home for that permission. You have to say yes if you want me to do this, because we want to show the world what's going on. Because I'm going to share with you guys this now. I'm going to ask you the same questions here. I want to get the equity gaps here now for fall 2019. Okay? Fall 2019. I want you guys to do the same exact thing here. Same exact thing. You say, what thing are you talking about? Use conditional probabilities for fall 2019. Let's see what you guys get. So in other words, let me write it down. Let's write it down. Number 5, this is now going to be for fall 2019 data. This is with the first year of AB 705. Okay, so this will be 5. Probability you are successful. Given that you are what? The first one was Asian. We'll do it the same order. Asian. Question 6. Probably you are successful. Given that you are black. Probability you are successful. Given that you are white. Probability you are successful. Given that you are Hispanic. Okay? And this time, I'm going to share with you the data from that course here. I think I have it right here. Let me double check. No, that's Titanic. All right, let me go here. This is the data. Now that you guys know how to do this, okay, put it right there. I'm going to give you time to do this yourself. We're going to see how well you guys do with this stuff. And before I do that, let me try to get this. There we go. We need a clock. We're going to give you guys some time to compute these things, okay? All right, get these success rates. Okay, ladies and gentlemen, let's take a look at this here. Let's see if you guys are able to get some correct answers here. Let's see if you guys can apply the definition. Now, number 5, probability you are successful, given that you are what? Asian, right? Let's color coordinate all this. Given that you are what? Asian. Is that right? Now, probably you're successful. Given that you are who? Black. Probably you're successful. Given that you're white. And probably you're successful. Given that you are Hispanic. So, okay, now, number 5, let's use the definition. Number who are successful and Asian. Out of the total number who are Asian. Okay, so let's see what you get now. So looking at this, you guys, I make the claim you should be able to answer these questions, right? You guys know what I'm talking about? So how many Asian students, if we can do it like this, how many Asian students were actually took Math 227 in fall 2019? 557, is that right? Of the 557, how many were successful? 388. Good. Let's see what this is. The TI. 388 divided by 557. And what do we get? What is this? 0.697. Is that true? Okay. And what is this as a percent? 69.7%. So, ladies and gentlemen, 69.7% of Asians were successful in fall 2019 due to, that's the first year of AB 705. So I'm going to put that here, 69.7%. I don't know. It already knows I want to put percent. That's interesting. Okay. All right. Now let's do the next group. Okay, next group. Let's shrink this. Number 6. Probability you are successful, given that you are, I'll put B for black, right? Number who are successful and are black, out of the number who are black. So how many black students, ladies and gentlemen, are in this table? Can you guys see that there? How many black students are here? Huh? Do you guys see 1,061? Good. Of the 1,061 black students, how many were successful? 460. Let's approximate this to the nearest thousands again. So that's going to be 460, going back, divided by 1,061. What do you think you get here? Oops. 460 divided by 1,061. What do you get here? This is approximately to the nearest thousands, 0.3. Is that 3.3 or 3.4? 0.43 what? 4. Okay, and then that's going to be, what is that as a percent? 43.4%. So, ladies and gentlemen, due to AB 705, you got 43.4%. All right. Okay, let's look at the information so far. So let's see. Asian students went from 71.9% pre-AB 705, and then they went to 69.7%. So in other words, success rates have dropped. Is that true for Asian students? And 47.4% for black students went down to 43.4%. So success rates have dropped there too. Okay, so AB 705 didn't give you an increase in success rate. So the probability now of being successful, given that you are white, number of successful students, and are white out of the total number of white students. Okay. So we need to find now, where are we at? Let's see if we can. Okay. How many white students are here? 945. How many of the white students were successful? 532. So that's going to be 532 out of 945. Is that right? So if you go to the TI now, 532 divided by 945. So what is this going to be approximately? 0.56. What's this? 3. Is that right? 0.563. Now, what is that as a percent? Yeah, what did you guys get as a percent? This is 56.3%. So 56.3% of which group of white students passed Math 227 in the first year of AB 705? 56.3%. So what we're going to do there is put that in our column. 56.3%. So if we kind of look at this here, white students took a hit. They went from 64.6 down to what? 56.3%. So white students took a hit, ladies and gentlemen. It's not just students of color necessarily. White students took a hit there in success rates. Do you guys see what I'm saying? It's kind of an interesting scenario. Asian students took a slight hit. Black students took a somewhat of a slight hit. White students took a bigger hit. Okay, let's see what happened to the Hispanic students. Isn't that interesting stuff, ladies and gentlemen? This is interesting. So let's see. Probability you are successful. I don't know who's at the door. Given that you're Hispanic. Number who are successful and who are what? Hispanic over the number of Hispanic students here. All right, here we go. So tell me here, this is now the group of Hispanic students. Okay, how many here Hispanic students took Math 227 in fall 2019, first year of AB 705? What do you guys notice? How many students? 6,807? Wow, that opened the floodgates. Is that true? The largest group, a lot more students took, Math 227. Now, of those who took Math 227, how many were successful? Of Hispanic students? 2,652. Is that true? Right? Can you guys read the table? Right? You guys see what I'm saying? 2652 out of 6807. Let's get the success rate for Hispanic students. 2,652 divided by 6,807, ladies and gentlemen. And what do you get now? 0.38 what? Well, it says 95 Okay, we're approximating to the nearest what? Thousandths, and that's going to be right in here. We look at the digit to the right. It's a 5. Remember, if it's a 5, 6, 7, 8, or 9, what do you do to the 5, to the 9? You add 1 to it. So it's like saying 9 plus 1, or it's like saying 89 plus 1. I choose to look at 89 plus 1, which gives me 390. So this is approximating to the nearest thousandths position. And as you guys know by now, what is that as a percent? Simply 39%, ladies and gentlemen. Okay, 39%. So 39% goes right in here. I'm going to keep track of this. Now, it looks like it already knew I wanted to do that. So, good. So let's compare. Let's see what happened from year to year. Oh my God. Hispanic students went from 48% success rate pre-AB 705, and then post every first year, you went down to 39%. The success rates have done what? Declined. So I would say to you, the two groups that look like they have suffered in terms of success rates, personally speaking, are the what? White and Hispanic students. Their success rates dramatically declined. Is that right? I'm telling you, those are dramatic. Asian and black students marginally declined. Or I don't know if they declined. I wouldn't say marginally. They certainly declined if you go back and take a look. 71.9, that's like 72 to about 70. So it's like a 2% decline. For Asians, black students were like 47.4. Oh, that's 4%. So the black students declined by 4%, but white and Hispanic students actually declined the most. So I would say AB 705 isn't so good for success rates with white and Hispanic students personally. All right, so if I was a student in those categories, I would look at that and go, wait a minute, what's really going on, right? What's happening here? So the success rates didn't, and in all honesty, it makes a lot of sense that success rates would go down. Why do you think that makes kind of sense? Yeah, you're just doing what? You're just throwing people in there without any check of anything that has gone on in the past with them, right? But remember what these authors say for these bills here, the author of AB 705, they said, you know what? Why don't you just get extra tutoring? Or you know what? Have your districts add what's called a co-rec, meaning you can take extra, like another math course that you don't really get credit for, co-rec, okay? Maybe another 3-4 hours a week, add another 3 or 4 units or something a week. So, you know, you can take this course plus the extra 3 or 4 units on top, and then maybe you'll get through a lot better, right? Now, why do you think that might be a problem? Okay, because we do have a college in our district that tried that, and I'll tell you what happened. But why do you guys think? Well, I'll tell you what happened at Mission College. They tried that. You know what happened? They didn't get people registering for the co-rec. They registered for the course, but not the co-rec. Why do you think that happened? Anybody have an idea? Maybe partly they weren't aware, but I think they tried to make them aware. They still chose not to take it. Why do you think they chose not to take it? It's maybe cost. I'm not sure if it was free, but yeah. Yeah, what starts to happen is, ladies and gentlemen, what people don't realize is this. As you start to add hours to any class, it doesn't matter what it is. If I said to you, hey, guess what, add another, if you wanted to take, let's say, college algebra, but you never took intermediate algebra, I'll say, okay, you only took beginning algebra, never intermediate, but you're enrolled in college algebra, add another 4 units on top, and you're taking intermediate algebra, college algebra at the same time. This is their concept of co-rec. Take them at the same time. The problems with that is this. Math is sequential. You got to take intermediate before college algebra. You got to learn arithmetic before algebra. There's things you got to learn before you move on. Asking people to do it at the same time is kind of like, to me, in my opinion, having somebody who has a flat tire fix the flat tire as you drive the car. You guys know what I mean? That's my impression of it. Clearly, these people have never done it themselves. Clearly, they write bills and they've never done it themselves that way. You guys get it? You guys understand? It's people who've never done it that way telling you how to do it. So I say, okay, that's kind of interesting. One of the things that has come up, because people say, well, just have them take the tutoring. Because I actually met with Jackie Irwin's office, the author of AB 705 and AB 1705. You know, and we expressed them some of the data. I shared with them the sheet that I'm sharing with you guys here. This sheet, you want to know what the attitude of it was? We got our own data. We don't really care about what you have. Now, I have witnesses there to this, so this is public. My witnesses can verify that. Okay? The witnesses verified the attitude. We got our own data. They said we had data from USC, we had data from... In other words, Daniel Judge's data or LACCD data didn't matter because they got their own data gatherers. That was the attitude. But I try to talk to them about these equity gaps and saying, you open the floodgates. Now, I did talk about this in my video already, but what I want to share with you guys is they talk about what's called throughput. They got a lot more students through. So let me share some of this detail. They're saying our bill is successful because we got more people through. And they did. If you look at the conclusion I have here, okay? 348 additional black students did not, here's the good news. 232 additional black students passed Math 227 for a 102% increase. They doubled the number of black students who finished 227. Now that is a good thing. Okay, this is their success. We're successful. They had 748 additional Hispanic students pass 227 for a 39% increase. It's not as big as the percent increase is not as big as black students, but you know that's 749 additional students. So they're saying we are successful with this bill. But if you look at what I call the complement of throughput, look at how many people that did not get through. I'm not looking at success rates. Look at the people who maybe swam across the English Channel and drowned. Okay, 348 additional, this is additional black students, did not pass Math 227. They, for a 138 increase in non-passing students. So although they increased the passing students, they more than increased the non-passing. And for Hispanics, 2,102 additional Hispanic students did not pass Math 227 for a 102% increase. They doubled the number of non-passing Hispanic students. Okay, you guys see what I'm saying? These are the additional, not the ones that didn't, these are additional. So, all right, you go, okay, what else is going on here with this? Well, we're not gonna, here's what I actually said here, or actually have for you guys to think about, right? I want you guys to think about the Titanic data. Because here's the bad news, right? This is what I computed. This is for the additional for Hispanic and for black students, right? The bad news is that while opening the floodgates certainly presented an increase in throughput, it also significantly increased the non-passing rate for black and Hispanic students. In other words, those students have what? They crashed, didn't pass. 1,031 additional blacks and Hispanic students passed Math 227, but 2,445 additional black and Hispanic students did not pass. Now here's where the unit ratio stuff comes into play. That is, for every additional black and Hispanic student who passed 227, 2.4 additional black and Hispanic students did not pass. What's that unit ratio here that I'm sharing with you guys? This is for additional. It is 1 to what? 2.4. Okay, 1 to 2.4. This is the additional. So you got an additional student of color through, meaning black and Hispanic students, and they say, good, we got that additional in throughput, but how much did they lose? An additional 2.4. All right, so that ratio is 1 to what? 2.4. Do you guys remember what I shared with you guys earlier when we started the lecture this morning? What was the Titanic? This is AB 705 for black and Hispanic students. Anybody have that in their notes? For the Titanic. For 1 to 2 point what? 1. This is the survivors to non-survivors on the Titanic. So here's the conclusion. Here is, whether anybody likes it or not, here's what you can say about AB 705 from fall 2018 to fall 2019. You have a better chance of surviving the Titanic than you do of passing Math 227 as an additional student by opening the floodgates, if you're a black and Hispanic student. That's what opening the floodgates did. So I'd like to compare these two so that people get a grip and say, So you go, so like Mr. Judge is Hispanic, and you know what? If you would have put him when he went to ELAC years ago as a kid out of high school, say, guess what, Daniel? You get to go to a transfer level, English and math course. We're doing this for equity reasons because our data suggests that you're not going to be able to finish all the courses to get there, right? That's what they're saying in AB 705. We did this for equity. Well, guess what would have happened to me? I probably would have been one of the 2.4 who didn't get through. In fact, I computed this specifically for Hispanic students earlier this morning. If we go back to this data and talk about the additional Hispanics, don't look at Hispanic and black, but just for Hispanic students, for every additional student they got through, 2.8 did not get through. Okay, I'm going to go back to this. This is for additional, and I'm going to try to find some of this. Maybe I can find it. No, this was you guys. All right, well, whatever. Here's how we computed it, okay? For Hispanic students, looking at, let's go to Microsoft Excel. Right, from fall, look at Hispanic students. I'm going to get rid of this color here. Fall 2018, yeah. We got 1903 and fall 2652. This is the additional Hispanic that got through. The ones that did not get through now, let's go back here. 2053, 4,155. 4,155 minus, what was that? 2053. Okay, this is what I mean by the additional Hispanic. And we're looking at this in the iPad. So we got this information in the iPad here. Okay, additional Hispanic. This is that pass or who are successful. And here we're not successful. So if I get those values here, 2652 minus 1903, 749 additional Hispanic students got through. How many additional did not get through? 4155 minus what? 2,053. So I'm sharing this with you guys here. That's 2,102 did not get through. Okay, this is the ratio. Only for Hispanic students. Now, I'm going to say this. Let's unitize. Remember this unitize idea? I love to unitize. You know why I love to unitize? It gives you an idea. This is now for every whole person. So we're going to unitize the successes. Divide both of these by 749 so that you get now what? 2102 divided by 749. So let's try that out. 2102 divided by 749. Let's go to the nearest tenths. What is this going to give you here, ladies and gentlemen? For every additional Hispanic students that you got through, because you got some additional Hispanic students through, but how many did not get through? 2.8. Okay, this is what I'm saying to you guys, that if you compare that ratio, those odds to surviving the Titanic, if you're a Hispanic student, surviving the Titanic was 1 to what? To 2.1. This is the Titanic survivability rate. 1 survivor to 2.1 non-survivors. You have a better chance surviving the Titanic if you're Hispanic than passing Math 227 from fall 2018 to fall 2019. This is why I say when you open the floodgates, what exactly happened? There's more than one side to the story here. They don't want to talk about this piece of information at all. They don't want people to know about it and talk about it, which is why we should make it what? Public. This is the stuff they don't want to tell you. Now, let's talk a little bit about this, because this is important too. You see, ladies and gentlemen, what happens to students if, for example, you're placed in a transfer level courses and you may not feel prepared for it, especially when you just came out of a pandemic and maybe you're an LAUSD student who, you know, during the pandemic, maybe you didn't do so well in your courses. Maybe you didn't show up very often. And then you come to college and they put you into this course, right? Because AB 1705 is saying what? They're saying AB 705 was such a great success because of the throughput. How many people got through? They're not talking about how many who did not get through. We should put every new student and existing student into transfer level English and math courses and forget about the option of a pre-transfer level course. Put them all in. Let them take their chances. Remember, we just got through a pandemic. People didn't go to school necessarily. In fact, 1 in 3 LAUSD students are at grade level. 1 in 3. I have that data I'm going to put on my website so you guys can see as well. So as you guys can take a look at this information, the stuff that they don't want to talk about that I'm showing you, which is part of our course, probability and statistics, and of course they have their people doing statistics making a lot of claims, right? But they're not talking about these things. And so how do you think some of those students might feel? Would they be apprehensive about taking an English or transfer level course to begin with? I would say yes. If they actually did not pass, how do you think they would feel? Would they be so eager to jump on the bandwagon again and try again the next semester and say, I'm just going to try again? They may not. This is what I was expressing to the author of the bill, Irwin's office. I didn't talk to Irwin, I talked to her office people. Okay, there's some apprehension. Let's think about this here. So you might be apprehensive. So what is the effect? The effect is students can become disenfranchised. What does that mean? discouraged. Maybe they don't feel that college is for them. And they might look into other options. Now, Daniel Judge Jr., as a kid, if I faced this, I wouldn't even gone to college. I would have went straight into the Marine Corps. There's nothing wrong with the Marine Corps. But, I've been there. I did make it there. It's not as fun as you think. It's not as fun as being, it's not fun being cold, tired, and hungry all the time. Trust me on that. I've had that experience. It's nicer to be in your bed, sleeping with a nice warm meal, and your biggest problem is studying for a test. That's a lot nicer than for me than, when I went into the Marine Corps, just to let you guys know. So it limits your options. So what does the faculty in our district say? You know what we say? Give students a what? Choice. Let them choose. If they feel they need to take a transfer level math course to prepare for themselves or English, they should have the right to a choice, especially given the pandemic and what's going on with LAUSD. It doesn't seem right, doesn't seem fair. Right? You guys understand what I'm saying? Give students a choice. That's all we're saying. And so, I did do some of those videos this weekend on just this worksheet, just so it's out there. And by the way, word has it that they're certainly aware that we're doing all this stuff. Good. Because I'm doing an expose on it, ladies and gentlemen. I'm doing an expose. Because there's a lot more to the story than you guys realize. You want to know why some of this could be happening? Notice the language I say. This is things I'm thinking out loud. I could be wrong, or I could be right. Because people are going to be hearing me say this. The new funding formula mechanism in the state to fund colleges, you know what it's based on? Enrollment. It's always been based on enrollment. And I'm going to simplify the funding formula because I'm not an expert on it. I used to be. Not anymore. Because they've changed things. They're going to base it on enrollment. People who show. That sounds reasonable. And then they're going to partly base it on, a percentage, is on success. They're going to base this on success. So if you successfully completed English and math in 1 year, you get bonus points for funding. All right? Sounds pretty good. Is that right? All right. Well, let me do something here. Let me find this here. If I go back to my website, remember I did this AB 705, right? I have this, the State Chancellor's Office has a dashboard on data. All right? Now, Jackie Irwin is a pretty darn good state assembly member. She's a Democrat out of Thousand Oaks. She's accomplished some pretty darn things. Some of the things she's accomplished, too, is bringing education dollars back to her district. Pretty good assembly member being able to do that kind of thing, right? Well, let's see, what does that have to do with this data? Okay, I'm going to look for data here. I'm going to share with you guys. Student center funding, okay. Where is the success rates? Whatever. Here we go, student success metrics, there we go. And I want to share with you guys this based on, you guys can actually go here yourself and tinker. You guys can look all this stuff up, I invite you to. This is a statistics course, right? You should be able to. And let's look at by college. Now, I think, and I could be wrong, Ventura College might be in Miss Irwin's district. I could be wrong. But, out in that area, Thousand Oaks and Calabasas, you guys ever been there? Pretty nice. Thousand Oaks and Calabasas area out there. It's pretty nice. Nice neighborhood. Wonderful neighborhoods out there. Pretty good. And all students. So what I'm doing here is I'm going to view the success rate data for Ventura College in math and English. So as you guys can see, maybe you can see, Yeah, you guys can see that here. Okay. In fall 2018, right, it looks like English is the blue. It's always higher than math. So 36% of their English students completed English in the first year. And then 18% of their students completed math in the first year. 15% completed in what? Completed both. That's the 15%. Completed both math and English within a first year. Now, notice their success rates increase due to AB 705 for some reason, right? So what you can see here now, completed English, 40% completed English in the first year. That's a pretty good thing. 25% completed math in the first year, and 20% completed both in the first year. So under the new funding mechanism, it looks like they're going to pretty much make out with what that success rate portion within the first year. You guys understand what I'm saying? And if students are successful within that first year, they're not going to drop out. They're going to stay. So they got the enrollment portion and the success rate portion. Good for them. Let's pick a college that maybe is known to have students of color. I'm just going to pick, what should we pick? How about if we try LA Trade Tech? Don't worry, we can see East as well. Let's try LA Trade Tech. Let's see what kind of success rates. Now let's look at that. Now, did their success rates in 2018 right here? I'll read it to you guys. You know what? In English, 12% of their students passed English in the first year. 3% completed a transfer level math in the first year. 2% completed both in the first year. Compare that to 2019 with AB 705. 13% completed English. 6% completed math, and 3% completed both. So their completions is marginal, small again. And they did not complete, it's not in the same stratosphere as, let's say, Ventura. So they probably are going to, have some disenfranchisement there, lose enrollment. So they're not going to win in this enrollment scheme, at least based on those two things. Now, that's as far as I know, so forgive me if there's more to the detail. Let's look at, for example, should we look at East? East Los Angeles College. This has enrollment implications, ladies and gentlemen. Now you can see how sometimes things happen. Let's look at East. Now, East, look at that. That's pretty good, though, in some degrees. Look at what's going on at East, right? 21% finished transfer level English in the first year. That's in 2018, pre-AB 705. And then that jumped to 26%. So they had a 21 to 26% increase in English. Math, 9% in the first year to 11%. It's a marginal increase. Now, both here is 5% to what? 7%. Again, a marginal increase. And again, they're low percentage rates, so you might have some disenfranchisement happening and people who are apprehensive in enrolling in those courses. This is transfer level English, transfer level math. If we look at Compton College, let's look at Compton College. Okay. State metrics. And this is what Jackie Irwin's office said, hey, let's look at these metrics. All right, let's look at them. Completed transfer level English and math, right? So it looks like they have had some increases. Let's see exactly what it is. English completed transfer level English in the first year went from 16% to 19%. That's a 3% increase. Math went from 6 to what? 9. Okay. both went from 3% to 5%, so that's a 2% increase. So even just comparing some of these based on demographics, based on where you live, there's some stark differences. Now, let's think about this before I give you guys a break. Why might you guys think in Ventura, in Jackie Irwin's area, if that college is even there in her service area, I think it is, but I'm not sure. I could double check. Maybe you guys can do that for homework, right? If you live in Calabasas and you start to put you in a transfer level math course, right? And there's some assumptions here, right? There are demographic issues. If I say to you guys as East students, why might you have trouble taking a co-rec or getting extra tutoring? Because students at East, maybe compared to Calabasas or something, or maybe in Ventura, Thousand Oaks somewhere, student at East might have to go to work right after class. They might have to take care of some kids. They might have to take care of some parents. They might have to do all three. Is that true? I'm going to ask you guys. Is that true? Is that what you guys have to face? If you're in Calabasas, you may not have to face those obstacles. Maybe it makes sense. You can actually take extra 3 hours a week, 4 hours of another math class at the same time to get through a transfer level course, because you don't have to necessarily go home and work. Maybe you don't have to necessarily take care of your kids. Maybe you don't have to necessarily take care of even your parents or grandparents. Just slightly different issues. Now, does that mean, or does that do you feel like the one-size-fits-all scenario that was written out of that district, do you think that that scenario applies to you in a fair way? I don't think so. That's my personal feeling. So this is why a group of us have decided, ladies and gentlemen, here, I'm using the data because this is statistics. This is how they compute this stuff. They even do some other funny stuff in their data gathering. But, I spent this weekend, I did this here. This is a disclaimer. This represents my views as an instructor. I got this academic freedom to present you. This is district data. It's not made up. Is this really a good idea? So I have this video here to watch. I also created here on my webpage, by the way. Maybe some of you guys think here, you see this? How to what? What is this? How to contact your California State Assembly person. I have that video here. It's a very short video. I might even try to put it on TikTok. Maybe people will see it on TikTok, right? So I put this here just in case students maybe had the urge to find their state assembly person and talk to them about AB 1705. It's very easy to find your state assembly person. And then I even put some talking points here. This is what I put in my, when I contacted my assembly person to let them know. If you're a student, then you can put student. If you're a teacher, you can change it to teacher. And you can send it to your friends and family, So you might want to consider contacting them and let them know how you feel about that bill, AB 1705. And this is the talking points. Of course, you're not required, but that's what I created this weekend on my own time using my own resources because of the data that I know how to compute, the data I know how to teach you guys. This is all right down our alley. This is all part of the course in the statistics course. So you might want to think about that, ladies and gentlemen. And should we give you your break or should we continue with this lecture? Oh, you want a break? All right. A break. But boy, that Mr. Judge is something else. He wears us out. Well, it's good to know. What do you guys think? It's good to know what's going on and what affects you. All right. It's good for you guys to see it yourself. So we'll give you guys a quick little break. And then I'll add some more definitions here. You're going to like this. We'll see you in a little bit. All right, ladies and gentlemen. Now, the definitions I gave you on conditional probability, if we go back here, let's go back. We're going to change some things here. Okay. I'm going to go to Math 227 and show you guys here, Statistics Online Transition. Remember, I have a conditional probability worksheet here that has some medical information. There's even a video on some of this that I'm going to go over for you guys. Put it there. And some examples here, some solutions there. For some, I did not finish one term. So what I want to share with you, if I go all the way back to that original conditional probability worksheet, that this was done about 2 years ago when we first went away for remotely due to COVID. So conditional probabilities can be used here as well, believe it or not. And let me make it bigger here, okay? So what I've expressed here, if you guys look at this worksheet here, if I go further, is that I made a fictitious data. I created the data. It was fictitious. We didn't have any data 2 years ago on COVID and infection rates. So I started to use what was coming out when it was coming out. Now, this is true. And if you guys were to take a pregnancy test, do you guys know what's going on? Anybody here take a pregnancy test before? Maybe you say, no, Mr. Judge, that's too much information. We're adults in here, right? There's no legal waiver if you're under 18, you know what I mean? So if you take a pregnancy test, if you take a marijuana test, what other tests could you take? You can even take a test for cancer. There's a lot of different medical tests you guys can take. You guys know? And in this table that you guys see is a COVID-19 test. Now, if you look at the details, take a look at that table. You might say, hey, Mr. Judge, some people can be infected. Yeah, if you look at the table. All right, let's take a look. In this table, right, 33 people were infected with COVID who were tested. 467 were not infected. And then you go, okay, those are my rows out of a total of 500 people. But then look at the columns here. What do you guys see in the columns? Some people test what? Positive. And some people test what? Negative. How many people tested positive? 120. How many people tested negative? 380. Okay, you guys okay with that? Now, we can create, and this is for those students who are like, you know, you say, Mr. Judge, I'm a nursing student, or I want to go into medical school or something. Well, it doesn't even matter. If you're just a human being, you might get tested for COVID or have a pregnancy test or a cancer test. Know that every test has error rates. There's some errors there. So we get to formalize this in the form of a conditional probability. For example, if you select a person from that table, person at random, they can ask you the following question. What's the probability the person, I'm going to ask you two questions here. Question one, test positive given that the person is not infected. Okay, so notice this question. Person is testing positive, and then you see this phrase. If you ever see given that, what does that mean? This is a conditional what? Probability. This is the condition. You're not infected. So symbolically by the definition I gave you. The probability person tests positive given the person is not what? Infected. I want you guys to see this definition. It's an extremely important definition. In fact, let's see how to use this, right? Remember how we use this. It's the number who test positive and you are not infected. You say, can that be possible? Yes. You know why that's possible? Because it errors in the, I'm sorry, I gave it to you backwards. I want to give it to you another question, I think. Yeah. Sorry. Let me change this on you guys. Sorry. Probability, you are, I got to change it on you. I made a mistake. I'm going to blame it on that bill. AB 1705. I keep thinking about it. Probably you're not infected given that the person tests positive. Let's change the color. Okay. When I wrote it down, I wait a minute, something's wrong here with this, okay? So here's the event. The event is not being infected. And what's known to have happened? This is the condition. Testing what? Positive. I had it backwards there. I apologize, ladies and gentlemen. I find it, it's not an error. You guys know that, right? Okay. Number who are not infected and test what? Positive over the total who tested what? Positive. This is what they're asking. Okay. All right, so we have to find out, look at the table. How many people test positive, and of the ones who test positive, how many are actually not what? Infected. This is a conditional probability definition we were learning today. So look at the table and tell me, how many people, ladies and gentlemen, in this table tested positive? How many people test positive? 120. Good. Okay, of the 120 that test positive, how many are actually not infected? 105. Outstanding. So you're going to put 105 out of 120. We're going to approximate that. 105 divided by 120. What do you guys get? This is approximately what? Is that 0.875? Is that true? Let me double check. Not infected, test positive. All right. What does that actually mean? This is a probability value. What does this mean as a percent? 87.5%. So here's what I'm going to say to you guys. What is known here is that you took the COVID test. What is known is that you test what? Positive. And you go, oh my Lord. Everybody, I got a positive test result for COVID or for a pregnancy test, whatever. But what does this actually say? This is a chance, you guys know this already, this is a chance that you're actually not infected. There's about an 87.5% chance. That's a high chance. You're right. This is known as a what? This is a definition of what we call a false positive. So false positives, ladies and gentlemen, they exist in the medical field. Now, this is maybe a pretty bad example because it was made up, but it's a bad test if you have an 87.5% false positive rate. You guys agree with see what I'm saying? It's pretty bad if that's your, false positive. You also have something called a false negative. That's like saying, what's the probability you are infected? Given that what? You actually test negative. So, ladies and gentlemen, this is a conditional probability. They want to know the chance you're infected. Given that, what's the deal now? You test negative. Okay, so I'll write this down. Probability you are infected. The chance you're infected, given that you actually test negative. Remember, this has happened. This is known. You've tested negative. So you're a person here who has tested negative. All right, you go, okay, I just test negative, but there's a chance you're actually what? Infected. Let's find that out. The number who are infected and test what? Negative over the total who test what? Negative. Use your definition, ladies and gentlemen. This is a definition. It's a conditional probability. We need to now know of all the people that test negative, right? How many are actually infected? Because everybody in this table was tested twice, so they found the errors. They found the error rates. Everybody, they don't tell you that, but everybody in this table was tested twice. Now, how many people tested negative? 380. Could you guys see that? The test negative column? 380. Okay, of the 380 who test negative, how many are actually infected? Now, that's the ratio, 18 out of 380. So when you go to your calculator, using this definition, what do you guys see this gives you? This is 0.0 what? 47 to the nearest thousands, right? And what is this as a percent? This is 4.7 what? Percent. So this situation happens 4.7% of the time. This is called a false what? Negative. So you got false negatives because testing has errors, ladies and gentlemen. There's errors in testing. Every test has false positives, has false negatives. Now, this is with made up data, so don't think that you just got a COVID test and, oh, Mr. Judge, you tested negative, and 4.7% of the time, that's a false negative, meaning there is a chance you're actually what? Infected. This is the statement probability of infection, given that you test negative. This is a false negative, 4.7% of the time. And here, 87.5% of the time, there's a false positive. So conditional probabilities can be used in these settings as well, ladies and gentlemen. So I did a nice worksheet for you guys here. I had a lot of fun doing it. And here's some probability questions you may want to consider. We do have things called false negative, false positive. We actually have true positives and true what? Negative. So anyway, ladies and gentlemen, then I have some other questions here. So I just want to let you guys know about this sheet and take a look. And ladies and gentlemen, we'll continue next time. But I hope you guys learned a lot about what's going on with probability and statistics. I hope I didn't discourage you guys, but study hard. And again, if you feel strong enough about contacting your legislator with AB 1705, certainly let them know you want to give students choice so that they can have more choices and not be denied any opportunities, okay? You guys okay? Oh, maybe they're trying to come to get me. All right, ladies and gentlemen, print your name for attendance purposes. We'll see you guys later. I put your homework in the Canvas section already, so get started.